Question number 2, how do you turn raw scans into 3D precision in real time? This feels like a loaded question, but I think it's a great one. A 3D scan is essentially a representation inside the computer of the size and the shape and the scale of what's happening in reality. 3D imaging is also called spatial computing, which means, hey, how do we know where things are in reality? And that gets down to the core problem, which is, hey, if we're going to use a tool in our procedure, we need the tool, the digital representation of the tool, to overlay the physical representation and for those things to be the same, right? And so when we talk about 3D precision, we really want to make sure that our images are accurate. We want to see that they're size, scale, and in some cases color accurate, but we want to make sure that they're in the same space at the same distance so that we can essentially know where things are. Now, the difference between taking a video, which is recording everything and analyzing the back end where things were, and real time is that real time is actually very complex because essentially you're feeding, analyzing all this data, and then reconciling it, and then spitting out an outcome and doing it fast enough that human perception can't tell the difference, right? Because if I show you a knee and 10 minutes later I say where that knee was, well, I can't go back and do surgery 10 minutes ago with the tool that I was trying to use for the surgery. So really what we're looking at here is solving for the problem of how much computer work can we do to resolve the data before anybody can even notice. And at VISIE, we've done that. We're working at speeds that are higher than human perception, and that's really interesting to us because what we can say is we can look at that, we can take all this data, we can analyze it, we can associate it to the knee, and we can give it back to you faster than you can think that it changed, which is a really interesting thing and a really interesting concept, and arguably a very hard problem to solve.